Hello dear students, in this video I will be solving ISI M.Tech QROR sample 2024, which is exactly the 2023 paper, the engineering section, which is the mostly unsolved everywhere. So the first one is a train with starts at W. Okay, associated with the force Fa, it keeps accelerating till it's such a point that the journey when the retardation is equal to Fr and would bring a stop at the point D units away from the starting point, so that the velocity of the train when it comes to its retardation is this. Okay, so to solve the velocity of the train when it comes to the retardation, we can use the principles of work energy conservation. Work energy conservation. Okay, so let the acceleration force is Fa is given and the retardation force is Fr, and the distance which travel before it stops in the acceleration Vx. So the total work done by Fa in the acceleration is Fa into x. The kinetic energy Ke gained by the train is half into W into V square, where V is obviously the velocity of the end of the acceleration. So work energy principle, Fa into x equal to half into W into V square. Okay, so during the retardation, the work done by Fr in stopping the train is Fr d minus x. Okay, so the kinetic energy lost by the train equal to half into W into V square. So again, by the work energy principle, we can say that Fr equal to d minus x equal to half W V square. Dividing both the equations by the first, we get Fr d minus x Fa into x equal to 1. Substituting these values Fr on this thing, V equal to square root 2 dFA by W into 1 plus Fa by Fr, which is the given expression. And as a proof, directly let's go to the 5b now. To two smooth spheres, each of weighs W and the radius of R, in the equilibrium of the horizontal channel of this thing B less than 4R, given in the figure 1, find the three reactions from the sides of the channel which are smooth and force of the area exerted by the spheres on each other. Okay, so let the reactions be like R1, R2, R3. Okay, with R1 and R3 acting on the same sphere, and let the force exerted by one sphere on the other is let it be force F. Okay, so for the equilibrium, R1 plus R2 equal to W, weight of the sphere, and R1 equal to F, that is Newton's third law. Okay, so for the equilibrium of the sphere on the right, so this is like R1, R2, R3 equal to W, and R3 equal to F as well, and therefore three reactions of the sides is R1 equal to R3 equal to F, R2 equal to W minus F. So the force exerted by the spheres on each other is F, which can be determined by considering the equilibrium conditions and the geometric constants B less than 4R on this given system. In this way you can solve it and send it to me. This is the end for this part.